This video is for KTU BTech Computer Science and Engineering, course code CS304, course name Compiler Design. In this video, we'll be discussing about Introduction to Compiler, why do we need a compiler to execute the program, features of compilers, types of compilers, and what are the two parts of compilation. Let's see Introduction to the Compiler. A compiler is a translator that converts high-level language into a machine language. So basically, a high-level language is written by a developer and machine language can be understood by a computer or the processor. The main purpose of a compiler is to change the code written in one language without changing the meaning of the program. And the compiler will spot and report the errors to the programmer. So error handling is there inside the compiler. So once they found an error, you can edit in the editor, compile it again and execute the program. Let's see how the execution process takes place in a compiler. So if a source program which is written in a high-level language is given to the compiler, it executes in two steps. So in the first step, the source program given to the compiler, compiled, translated to the object program. This object program is given as an input to the assembler and that translates into a target program. I repeat, initially the source program is given to the compiler that compiled and translated to make an object program. This object program is given as an input to the assembler and translate that object program to a target program. So these are the two steps for the execution of a compiler. So in one way, we can say source program given to the compiler converts into a target program. And these are the two steps. I'll explain it further with an example. And there is a question comes in your mind, why do we need a compiler to execute the program? So computer cannot understand the source code. Okay, it can understand only binary language or machine language. And source code are human readable format because it is developed by the developer and he uses only high level language. So some compiler act as an intermediate between a human readable format and a machine readable format. How this process takes place? So the compiler parse the source file, translate into a machine understandable object file. So in one way, we can say that source file translated to an object file. And example. Take this as an example. We have a source code which is written in C language. Okay, and this program is to print hello. This is given to the compiler and each and every line of code is converted to a binary object code which is of executable. Now let's see how this is carried forward and what happens in each stages. So these are the steps for language processing system. For example, consider source program which is written in high level language and let it be hello.c as in the previous example. That is given to a preprocessor. The preprocessor convert the hello.c to an expanded source program or you can say as a modified source program and it uses an extension hello.i. This hello.i is given to the compiler and converting it into an assembly code using an extension hello.s. This hello.s is given as an input to the assembler. So the assembly code converts into an object code with the help of an assembler. So relocatable machine code means it's an object file. So after the creation of object file, linker will convert that object code to an executable file. So loader will execute all the loader will load the executable file for further execution, and thus making source program to a target machine code. I repeat, consider our source program which is written in high-level language, in our case hello.c, that is given to a preprocessor that converts into an expanded source program, or you can say a modified source program, and it uses an extension hello.i. This hello.i is given to the compiler. This compiler is translating, the hello.i is given to the compiler and translated to an assembly code which uses an extension hello.s. This hello.s, with the help of an assembler, converts to an object code, and whenever it needs a library files, it accesses the files from the library files. And once the object code is created, linker will convert that into an executable file, and the loader will load the executable file for execution, and thus making source program to a target program. Now, we'll go each phases in details. So the preprocessor, what happens is our source program is written with the help of a text editor, and we use as an extension .c in our example. So this source code is first parsed to a preprocessor. This preprocessor converts that into an expanded source code, and this expanded code is given to the compiler. We have an interpreter too. So interpreter is almost like a compiler which translates high-level language to a low-level machine language. And there is a difference between interpreter and the compiler. So interpreter reads and transforms each code line by line, whereas a compiler reads the entire code once and creates the machine code. I repeat, the main difference between an interpreter and the compiler is interpreter reads and transforms the code line by line as one person translating a language to another language, and compiler reads the entire code at once and creates a machine code. Now comes the assembler. So main aim of an assembler is, so assembly code is converted to object code by using an assembler. So in our case, when we are converting the hello.c, it uses an extension hello.obj. If we are using those, we'll be using .obj as extension. If we are using Unix, it will be .o. Now, linker. Linker helps to link and merge various object files for the creation of executable files. So the main task of linker is to search for called modules, which is in a program, and find out the memory location where the modules are stored. And loader means it's a part of an OS which perform task of loading executable files into memory and run them. It also calculates the size of a program, which creates additional memory space. Next, the key factor that you should keep in your mind is cross compilers and source to source compiler. So cross compiler is a platform which helps to generate executable code, whereas a source to source compiler means source code of one programming language translated to a source of another language. So these two, keep in mind these two terms, that is a cross compiler and a source to source compiler. Now comes the features of compiler. So the compiler has got 4 important features. 1, to determine correctness of the syntax of program. Second one is generating correct and efficient object code. Next is the runtime organization, and the last, formatting the output according to the assembler or linker. So the compilers always focus on the programming language syntax and semantics, Once it is correct, it creates an efficient object code that is happening in the runtime, and formatting of output happens within an assembler or a linker conversion. So these are the features of compiler. Now comes the types of compilers. There are basically three types of compilers. One, a single pass, another two pass, and third is a multi-pass compiler. Now let's see what's a single pass compiler. As the word meaning says, the whole source program is given directly to the compiler and transformed into machine code. Example for such compiler language is an assembly language. Pascal language. It is a Pascal language. Now comes the two-pass compiler. Here, the source program is given to the front end. As we can see that the compiler section is divided into two. That is a front-end compiler and we have a back-end compiler. So in the front-end compiler, the source program is converted directly to an intermediate code, or you can say intermediate representation, that is denoted as IR. This intermediate representation translates into a target code with the help of a backend. And the advantage of having a two-pass compiler is it simplifies the retargeting project. And this happens with the help of multiple front ends. Next comes the multi-pass compiler. So in the multi-pass compiler, the compiler section is divided into three, that is front end, middle end and the back end. Source code given to the front end and generate intermediate code. This intermediate representation is given to the middle end and optimized intermediate representation is given as the input to the backend and then generating machine codes. Or in a way you can say that multi-pass compiler processes the source program or a syntax tree several times. And how that is possible? We divide the large program into multiple small programs and process them. While we dividing and processing, we are developing multiple intermediate codes. And the middle end always focus on optimization. So optimization happens in the middle end. All this multi-pass takes the output of the previous phase as input. In a way, it reduces the memory. And that's why it is called wide compiler. Wide compiler. Now comes the two parts of compilation. What do you mean by compilation? So process of converting one language to another is called compilation, and this is happened with the help of a compiler. Now comes the structure of a compiler. So structure of a compiler consists of two. One is an analysis and the second one is synthesis. So in the analysis, what happens is a source program is divided into components and imposes grammatical structure and thus uses a structure to create intermediate representation. And you can relate this intermediate representation as in the front-end compiler. So the front-end compiler always check the program correctly, which is written in terms of a programming language, syntax and semantics. What do you mean by syntax and semantics? Syntax means if you want to declare a variable, there are certain rules for declaring a variable. It should have a data type and a variable name. And in the rule for declaring a variable, you should not start a number. Okay. So that's an important thing, that, and it should not take any special reserved word for declaring a variable. So these are syntax and semantics. So if you missed a semicolon at the end of declaring a variable, you made a mistake in syntax. Now, instead of assigning a value to a variable, you put the value and give a variable. It doesn't make any sense. For example, a equals 10. I'm declaring a variable, assigning a value to that, and I'm saying a is equal to 10. Instead of that, I'm saying 10 is equal to 8. Does it make any sense? It's an unmeaningful word. So it loses the meaning of the sentence, and that is what a semantic error is. Now comes, we have source program. So information about the source program is collected and stored in a data structure, and we named it as symbol table. So these consist of our analysis part. In the synthesis part, we have an intermediate representation that is passed through the synthesis phase, and we create a target program. So we can consider this as the back-end compiler. So back-end compiler is responsible for translating intermediate representation from the middle end to an assembly code. So from this we learned what is a compiler. So compiler basically translates high-level language to a machine language, and the purpose of a compiler is to convert one language written in one code to another one without changing the meaning. And role of a compiler is to spot and report error. Next, we learned why do we need a compiler for execution of a program. So always a compiler acts as an intermediate between a human readable format and a machine readable format. And we learned about different stages of the language processing system. So we have a source program. It is given to the preprocessor and it is converted as an expanded source program or a modified source program. That is given to a compiler, converts into an assembly code, and this assembly code is given to the assembler and converts into an object code. This object code is after the object code creation, Linker converts it into an executable file. So loader loads the executable file for further execution. So these are the stages for language processing system. Next comes the features of compiler. So features of compiler is determining the correctness of the syntax of program, generating the correct and efficient object code, runtime organization, formatting output according to the assembler or linker conversion. Then comes the different types of compiler. So we have single pass compiler, source code given directly to the compiler to convert machine language. In two pass compiler, we have the compiler section divided into two, a front end and the back end. And in the front end, the source code converted to intermediate representation, and in the back end, intermediate representation is given and converted to a target program. In the multipass compiler, we have a front, middle and the back end. Source code given to the front end to convert into intermediate representation. This intermediate representation is given as an input to the middle end and convert into optimized intermediate representation. That is passing through the back end to generate the target program. Now come the last, that is the two parts of a compilation. So two parts of a compilation is analysis and synthesis. So in the analysis means the large source program is divided into small programs, imposing the grammatic structure and thus creating an intermediate representation. And you can relate that with the front-end compiler. So the source program converting into an intermediate representation, and information of the source program is collected and stored in a data structure called symbol table. And at the last we have synthesis phase, that is intermediate code translating into target code. You can relate that as a backend. In the next class, we'll be dealing with phases of compilers. So here we learned the two parts of, structure of a compiler, that is of analysis and synthesis. In the next class, we'll be dealing with different phases of compiler. Hope you liked the video. If you have any queries or rectifications to be carried out, please feel free to comment in the comment box. Thank you.